All right, everyone. I decided to make a lesson where I'm talking through it because maybe some of you missed my voice. I don't know, but I thought I'm going to make this one for you guys. It's pretty straightforward. Hopefully, this won't be too long and you guys will understand what's happening. Um, so, let's see. The other day, we talked about lateral and surface area of prisms. Sorry if you hear background noise. It's a nice day out and people are doing their yard work, so that's what you might hear in the background. Dogs barking, people edging their grass, mowing their lawn, whatever. Um, so the other day we talked about surface and lateral area of prisms and cylinders and spheres. And so all of those figures um, were pretty much the same except the sphere. When we switch over to pyramids for today, notice a pyramid has this top point, and that's the difference between, the prism and the pyramid. Um, and so there's different parts to pyramids. So I wanted to identify those and make sure we understood what each of them are. So there's some terms that you're going to be reading, and I want to make sure we're clear on what they are. So the first is a lateral edge. A lateral edge is where two of the, we call it the face. The face is like this right here would be a triangular face for this pyramid. It's where two of the faces meet. That is your lateral edge. So I'm going to highlight that in red right here. So that is your lateral edge. Two faces that meet. So again, if you look at the pictures below, that would be the lateral edge. Okay, where two faces meet. The next thing is the slant height. The slant height. The slant height is the distance from the vertex of that pyramid, so in other words, the top of the pyramid, perpendicular as well as bisect the base of the pyramid. So the slant height is from the vertex, drop it down along the face of the pyramid, and it is perpendicular and bisects whatever the base is. If it's in this case, a square, a heptagon, a hexagon, an octagon, whatever the base is, the slant height is perpendicular and it bisects the base. All right? So that's what we have so far. The lateral edge is where two faces meet. The slant height is from the vertex down and is perpendicular and bisects the side of the base. The last is the altitude, the height. So the altitude again starts at the vertex, but it goes straight down to the middle of the base. And again, an altitude is perpendicular and it goes directly into the middle of the base. So if I were to draw a line right here, these two parts would be congruent down the middle of that. All right, so the altitude is from the vertex, drops straight down, is perpendicular to the base, and also if you were to connect that right there, it would bisect it, and that would be the same as, whoops, that's a bad line, but as the diagonal, okay? So again, right here from the vertex down to the edge of the base, that is your slant height. They also use a fancy L for that, a cursive L. This right here would be your altitude or the height of the pyramid, okay? And then again, one more time, this right here is your lateral edge, okay? So a lot of times with what you're given, you may have to use Pythagorean theorem to figure out one of the missing pieces. You may have to use special right triangles to figure out the missing pieces, all depending on what you're given. So the two formulas that we're going to focus on today for pyramids are lateral and total. So remember the difference, lateral versus total surface area. The lateral area is only the area around, and it does not include the base, okay? So it's just the amount around it. So if you were to think about a snow cone wrapper, right? That cone that's like this. The lateral is just the stuff around because a snow cone holder doesn't have a base, right? So that's the lateral. Total surface area includes the base. So that's why we always add the B. And for cylinders and for prisms, we had two bases, so we added 2B. For pyramids, we only have one base, so we add one area of the base. So again, let's talk about this formula. We have 1/2. It's 1/2 because everything is slanted in to meet at this top vertex up here. So that's why it's 1/2. P stands for perimeter of the base, and this cursive L is our slant height. All right, so that's lateral area. Total surface area is one more thing. It includes the area of the base, right? So big B is area of the base. Big P is the perimeter of the base, and your cursive L is your slant height. So now I have one example, so let's go through that. All right, here's the example. So we have a hexagonal pyramid. So remember, hexagon is 6 sides. Pyramid, so that tells us the formula that we're going to be using. And it has a side length of 12 and a slant height of 8. So I've already marked that on my diagram. Notice the slant height started at the vertex of the pyramid and went along the face, and I drew it was perpendicular. Okay? So I'm going to find lateral area first. So lateral area, we need to find perimeter of the base and slant height. Well, that's pretty straightforward. We have 12 is the side, and we have 6 sides because it's a hexagon, so that gives us 72. So we have 1/2 perimeter of 72 times a slant height of 8, and if we multiply that all together, we should get a lateral area of 288. We're talking area here, so we're going to use units squared because the units were not specific. All right, pretty straightforward there. We didn't have to find anything. The next is the total surface area. So remember, total surface area is everything is the same, 1/2 perimeter times slant height, but now we're adding the area of the base, which is the tricky part in this case. Whoops, sorry about that. I did not want to turn this around so much. Sorry. I thought everything would move when I did that, and it didn't. So we're going to keep this with what we just found out up above, 288, but we need the area of the base. So the area of the base, this base is a hexagon, which is a regular polygon. Remember, area of a hexagon is 1/2 perimeter of it times the epithum. Okay, so we have the same perimeter, so we have 1/2 of 72, but we need the epithum. So I'm going to walk through this because some of you on your test had trouble with this, so let's talk about this. That right there would be considered a central angle. Okay, so to find that central angle, we take 360 and divide it by how many angles there are. Since it's a hexagon, there's 6. That gives us 60 degrees. So that big angle right there is 60 degrees. Now, in order to find the apothem, we draw it. So the apothem is from the center of that hexagonal base, perpendicular to the side or the edge, and is the bisector. Okay? When we drew that apothem in, it bisected that central angle of 60. So now we have a 30 there and a 60 here. When we drew that apothem, not only did it bisect the central angle, but it also bisected the side of 12. So now this is 6. So as a review, I'm going to put my 90 degree there, just like the picture we have up above. I'm going to do 30 up at the vertex and 60 over on the side. We know the side across from 30 is 6. That was half the side of the hexagon. The apothem here is the side across from 60, which is the side across from 30, RW, 6 root 3. That is our apothem. Now, some of you on your test, when you were using pentagon or octagon or whatever, you don't wind up with a 30-degree angle right here. You wind up with something like, I think, 22.5 or something like that. In that case, you would have to use trig, your SOHCAHTOA. All right, so let's finish this up. So now let's figure out what this is. So we need half of 72, which is 36, times 6. So we have 216. So if we were to write this exact, right, for whatever quiz, test, maybe I say leave it exact. This right here would be exact, all right? That's your exact. If I asked you to round to the nearest, I don't know, 10th, we would actually add everything together. 288 plus 216 square root of 3 is 662.1 units squared, right? So that also should have units squared there. Okay, total surface area, you add the base. L, that's your slant height. You may have to find it. It may be given to you. So I hope this helps. Let me know if you have any questions on this. I hope you watch this video, and I hope you have a wonderful, wonderful day.